Hello and welcome back. Now let's actually create our website, which allows a user to upload an image, and he or she will then click the predict button and get back the prediction which our model is creating, right, based on the image. So how do we do this? Well, we learned about the basics of Streamlit here, but now we need to kill this website and start a new Streamlit option, right? So if I go to my folder here, you'll see that I have already created a new Python file, which is this app.py. However, if I double click on it, you'll see that it's currently empty. So there's nothing inside. You just need a new file because I don't want to overwrite the stream. The str file, this will be available in the resource section for you to download if you want. So we have a new file. I simply name it app.py, but you can name it whatever you want. Okay, so that's the first thing. Then I also added the fnet h5 file. This is simply the efficient net which we have trained, and I simply download the weights and save this so we can use it to make our prediction. Refer to this specific file here so we don't have to retrain it. If you want to use this file as well, I try to provide it in the resource section. I'm not sure if it's possible to upload this, but if it is, then it's available for you. Otherwise, of course, if you've trained it, if you followed along the course, you can use the efficient net yourself using this model.save option we had, just to save it somewhere and then refer to your own model if you want. Okay, so that is that. That's actually for the steps to start. So we got those, and now we can write our code. At first, of course, we need to import a few dependencies. So from my point of view, this is something I always do. You don't have to do it if you don't use them, of course. But I always import pandas as PD, and I also import numpy as np. This is something I always do. Okay. So then I want to import, let's say, TensorFlow, and then I also want to import TensorFlow.keras.backend as k, and then let me actually also import TensorFlow, or let's say from TensorFlow, from TensorFlow import keras, okay, keras like that. So we got those. Okay, and then I also want to import pillow, so pill, just to display the images, and then that's actually it. Actually, I think that's all we need. Otherwise, of course, we want to add something later on. So why we import this backend k? Well, when I tried to use the efficient net, which we created, trained, and download, when I tried to use it, I ran into a serious error, and I could not figure out a solution for that. But then at the end, it took me quite a lot of time, but then I found something. And what we need is a specific class, which is, I pasted inside, which is this one here. And I can't give you any more details about that. I just read that we can't use the efficient net if we don't import this fixed dropout class here, which is available. And that is why, of course, this code is in the resource section, so you can download it and, of course, and use it as well. So you can also try it without this class and the following along. So when we use it, but I had to use it. So I just want to mention that. So probably you have to use it too, but you could also try it without this class. Okay, so that's why I simply copy-paste it inside, because I really can't explain why it's necessary. I simply needed to create or use my efficient net model. So, okay, that is that. And then we can create the model itself. So the model is equal to, we can simply say it's TensorFlow. Let's say TensorFlow, or TensorFlow. You can also use abbreviation TF, but then of course you need to say import TensorFlow STF. So TensorFlow, and then say .keras.models, .load model, and now we want to load a pre-trained model, right, which we have. And in our case, it's this fnet h5, so I can refer to fnet.h5. And I should be able to do this because it's in the same folder, right? So if I go in here, the app.py file is in the same folder like this fnet.h5, so I can refer directly to here to it instead of using a complete file path. Okay, that is that. And then I also specify two additional things. Compile is equal to, in this case, false. And then I also say custom objects is equal to, and now I need to give it here a dictionary. And here I specify exactly this fixed dropout. And then I say this is equal to this class, to this fixed dropout. Okay, like that. And then I can close this here, and I also can close this here. Okay, so those two things here. So that's actually what I had to do. So compiling to false and set this custom objects here to this fixed dropout as a dictionary to fixed dropout to this specific class. So before I tried simply to load the model like that and basically leave everything else commented that out. So that was my original way to do it, but there I ran into errors. And then I figured out on the internet that basically I have to do it like that. And that would be a way how this would work. Okay, so as I said, you can try it out, but you might run into problems as I did, and you want to use this fixed dropout option here. Okay, so then we can write a title. Let's say st.title, st.title, title, and then we simply say for this title predicting, let's say rock, paper, scissors, right? Paper, scissors, like that. Okay, and of course I can then I have that. I can basically Control S to save it, and if we then go, for instance, to that, of course we need to kill our current Streamlit file which we had. So if we go back in here, so you can see now it's connecting, it tries to connect, but we killed it. So if you run it right now, you won't see site can't be reached. But if you go back in here, and instead of using our original ones, we simply say streamlit run, and then app.py this time. So not the str.py, but the app.py. And we can run this now, and you can see now it's running. And let's actually take a look. And please wait just a sec. It's running, and cannot import name Keras from TensorFlow. Let's see, because Keras is written in capital K. Okay, that's not a problem. Let's go back in the code here and say here import Keras, of course, small k here. Control S to save it, and we go back here to our application and say always rerun here, and you can say name fix dropout is not defined. The next thing, of course, I need to spell it correctly. So there is fixed dropout like that. Okay, make sure that this is the same as here. Control S to save it, and if you go back in here, streamlit app.py, let's see, it's running, and name st is not defined. Let's say because we do not import Streamlit. Okay, finally, so import Streamlit as st. Okay, like that. And Control S to save it, and let's go back one more time to our app, and we can see that predicting rock, paper, scissors. Okay, so I'm sorry for that, but this often happens. So it's simply a few things you need to adjust, like for instance, you forget to import a certain library, or you have a lot of spelling mistakes. At least that's something I encounter all the time. So I'm sorry, but that's probably for most other users, that's also probably the case. Okay, so we imported everything, Streamlit, don't forget that, and write fixed dropout correctly, and you see that now the st.title is available here, predicting rock, paper, scissors. Okay, so far so good. Now, what do you want to do now? Let's actually add subheader here. Let's say st.subheader, like that, and then we can see predicting the image. Let's actually put it in quotes, of course. Predicting uploaded images. Okay, like that, for instance. Control S to save it. Let's go back to view here and see it's running. Rock, paper, scissors. Let's see. Take a little bit of time, but here predicting uploaded images. Okay, so that's fine. And now we need to give the option, or the user the option, to upload an image. This is something we have not covered in the basics of Streamlit, but it's quite easy here to do as well. But please make sure you have the latest version of Streamlit, because in earlier, prior versions of Streamlit, this option was not available. So you need to have at least, I think it's 0.6, but simply install the latest Streamlit version for that. Okay, so in here, just in case you have installed it before, maybe a few months ago, then from today, so from 2020, July is today. So if you have installed it, let's say at the beginning of 2020, you might have to update it. So, okay, st.subheader, predicting uploading images. Okay, so that's fine. And now we simply say up, so, or upload, whatever you want to call it, is equal to st.fileuploader. That's what it's called. And then we need to specify here two things. At first, let's say some text. For instance, choose your image, like that. And then we can also specify the type. So if you want to be pretty specific here, I can say type is equal to, and then I can simply say PNG, Okay, here for instance I can specify it like that, because if I go back to my folder here, this one, I'll see that here my scissors is a PNG file, and all the other files which by default from this rock paper scissors dataset are PNG files. That is why I can be pretty specific here with PNG, but then of course you would run into issues if someone is now uploading a JPEG file. Okay, so that's if you don't specify the type here specifically to PNG files, for instance, what we do here. Okay, then you have to adjust it, but that's fine. We have our file uploader here, and of course we can also now, if I click Control S to save it, and if I go say to your view, and you see that now drop files upload here or browse files. So you can either click on browse files and choose a specific file, or you can drag and drop a file inside. So also a great option which is available in Streamlit by default. Okay, so that is that. And if we go back to the Python file here, we can, so here we got those, that's fine. And then we import, let's say from pillow import image, even though we imported pillow here directly, but of course let me actually say pillow import image, or you refer to pillow.image, also option pill.image. But let's say use the image here directly. Let me actually put this up there, right? So let's do it differently. Control X here, and it's actually, instead of pasting here pillow, we simply put it in here like that. And okay, so we can use this image now. Let's actually go back here and say for the image here, if up. So again, with the if condition, we check whether someone has uploaded a file, because if there's no file, then we can't display anything, right? So that is why I say if up. So if someone has uploaded something, then we can simply say image is equal to image.open. In this case, we want to open the uploaded image, so I'm referring to up here, and then I can simply say for this up here, I want to also make sure that it's convert to RGB. Okay, RGB. Just make sure that is 3 color channels RGB and not 4 color channels, which I think is default for PNG files. Could be wrong. Of course, you can then tell me that. But I think that should be the case. So that's done. Okay, we stored an image, and then we can basically write this image simply by calling st.image. Okay, st.image, and we're referring to the image file itself, like that. Okay, so that is that. So we uploaded a file here, store it in the upload variable or in the up variable, and then we check whether there is something in this up variable, whether it exists. If that's the case, we want to open it, we want to convert it to RGB, and then we can simply want to display it with st.image. Okay? Okay, that should be that. And now let's actually try that. Control S to save it, and let's go back to our model here, or basically our website. We can see drop files, browse files, that's fine. Okay, and now we could actually add something here. So if I go to the folder here, use this one here for instance, and let's actually drag our scissors here inside, like that, and we're uploading it. And let's just wait a little bit, scissors PNG, and here is the file, right? So the image is displayed here. Okay, of course, as I said, you can also click on browse files and go to the file directly, or you can drag and drop it. So that works, that is great. So let's actually go back in here and do the rest. So we got our image now, and of course now we need to classify that, right? So let's actually do that by simply calling, at first, create a dictionary, because otherwise our model is only able to return numbers, right? So the person who is uploading the file wants to know whether the model can predict this, so he or she wants to know, or wants to get back basically, this is a rock, this is a paper, this is a scissor, right? He or she doesn't want to get a number like 99%. Okay, but what is this number telling me, right? So we need to give this specifically. So again, we are referring to a dictionary, say labels is equal to, and we simply specify 0 is equal to this is a rock. Then let's say 1 here is equal to, 1 is equal to this is a paper, and then of course 2 then is equal to this is a scissor. Okay, this is a scissor. All right, here we go to our dictionary, and then we want to give the option with a button. So click on the button to make a prediction. So we simply say if st.button, and we can call it simply predict. So you can give it some text here. So predict. And then we want to check whether someone clicks on this button, which is called predict, and if that is the case, we want to use our image. Then we need to make sure that we resize the image. Remember, the original file which we had, or the original model, the efficient net model, was trained on 32 by 32 images. So we need to do the same kind of pre-processing steps for the uploaded image which we did for all the training and testing data when we created the model. So we want to make sure that the image is resized properly. So image.resize, and we simply say 32 by 32 pixels for image width and image height. Of course, if you use any other kind of pre-trained model, you need to make sure that you have the right image size and width here. Of course, you can adjust this. Remember, the mobile net, for instance, used 224, but in this case, we're using the efficient net, which uses 32 in our case. Okay? So we resize the image to the correct size for the model. Then we make sure that, in this case, let's actually store it in the image variable. Let's say image is equal to, so we resize the image. Then we want to store it in a variable, and oftentimes I'm using x simply, but of course you can also name this banana if you want. So x is equal to, and now let's simply say np.asArray, so we want to convert it into an array image. So now we have it in an array and stored in x. Then we want to make sure that it is float, so x is equal to x.asType, and then specify float 32. So we convert it into a float, and then of course we want to also normalize it, if you remember. So x is equal to, or divided equals to, let's direct like that, 255. Okay, so we normalize the data as well, the array, and then we need to make sure, because we only got one picture here, that the model, or that the dimension, the first dimension gets an additional, or there's an additional first dimension, call it this way, because currently the image looks like 32 by 32 by 3 pixels. And what the model needs is, whenever you want to predict only one image, it needs a size of 1 times image width times image height times color channels. So basically 1, 32, 32, 3 instead of 32, 32, 3. So we need to expand the dimensions. And we can do this using NumPy. So that is why it's always a good idea to import NumPy, because you use it pretty often. So you can simply say here x is equal to np.expand dims, expand dims, and then we specify here, okay, we want the dimension of x, and then which dimension? The axis is equal to 0, so the first dimension. Okay, so we got this as well. And now we can make our prediction. We can simply say our prediction is equal to, and say model.predict, just make sure we imported the model up there, the model is available, so we can predict something. We want to predict, in our case, here simply the image itself, so x, and then of course we can also specify now the class number is equal to, and simply say np.argmax, so get the maximum, the highest value of the prediction. Let's call this prediction here, so get the maximum value, and then of course when we have the value, it would be a 0, a 1, or 2, then we can use this labels dictionary to look up the number and then simply return the specific key, the value here from the dictionary. So then we can simply say we look up the key, we return the value, so class number is then the key, and we can simply say st.write in this case, and say here labels, so from the labels, and we're referring to the class number, spell it correctly like that, okay, class number, that's fine. So we can save this, and let's actually go back now to here the Streamlit application. It's running, just a second, and here we go. And that's actually, you can see we got the predict button here as well. We got our image, and now if we click on predict, just a second, the model is loading, the file gets uploaded, and we can see it's still running here, and this is a scissor. Here's the output, right? So that's how basically that works. So we can see we can pretty easy create the structure using Streamlit here. We can upload images here. The image, we can also display them. We can add additional information if you want, and then simply create a button. And with this button, we can refer to the model which we have created before during the course. We can simply load this model here. So instead of training it from scratch, we simply load the model here, the weights, we store it in a model variable, and then we can use the model. We just need to make sure, and this is often the most important part, here, which is often an issue because you might run into issues here, is when you pre-process the data. Because you need to make sure that the image in this case is exactly the same way, or pre-processed the same way as we've done for the training, the network, as well as also the test data for training the network. So we resize it here to the right size, we convert it to an array, we make sure it's data type float 32, we normalize the data, and we expand the dimensions, right? And then we can make the prediction and get back the maximum, or the argmax of the prediction, to get the number itself, and then we simply refer to a dictionary here where you can look up the number and then return the specific image, so what the model thinks it is, right? And the model thinks this is a scissor, and in this case the model is right. Okay, so that's it actually for deploying the model with Streamlit. So hopefully that was interesting to you, hopefully you enjoyed it, hopefully you were able to follow along, and hopefully you followed along. And that's it for this video. Thanks a lot for watching and your attention, and can't wait to see you in the next video. Until then, best guys.